Hello. Welcome to my channel, my data farm. In today's video, it's Henry, your favorite data engineer. In today's video, we're going to talk about recursive queries. We're going to create recursive query. And what are recursive queries? Recursive queries are queries that automatically run to reproduce values that you specify. For example, you want to run a query or write a query or a code that reproduces values from 1 to 10. And this can be done using recursive query. You just write a query and the query reproduces the values from 1 to 10 for you without you providing the numbers. All you need to do is to just provide the first value, which is like 1, and then the code just runs by itself to produce the final value for you. Yes, great. And this kind of queries are asked during interviews these days. They want to be sure that you understand the concepts and the logics behind writing these codes. And as such, in a live interview session, you can't be asked to write a recursive query where you code live and then produce these values. But in this video, I'm going to solve that problem for you. We're going to write a recursive query in SQL and write a recursive value, same in PySpark and SparkSQL. So just follow me. Let's get this done. Writing. All right. Yes, as stated, recursive queries are one of the most asked live coding tests during interviews. So I'm going to demonstrate we're going to create a recursive query that will produce numbers from 1 to 10. You could increase it as you prefer, right? But for this particular video, we're going to do it from 1 to 10. And as I said, recursive query reproduces at itself. So we want to produce numbers from 1 to 10, but we want the code to be the one to initiate that, as well as when it reaches the number 10, the query should stop and then produce those values for us. So let's begin. Let's create our query editor and name it recursive underscore SQL. Great. So we have our recursive query editor. Now to begin, to create a recursive query, what you need to do is to begin with width, because in this case we're going to just specify tell SQL the first value we want it to begin from, which is 1, right? So we say width, and in SQL there's a function called recursive, and that's what we're going to use. SQL is going to take the first value you produce and add 1 to each time round it goes 1. It's like a loop, right? It goes on and on. If we start from 1, SQL will go back and then add another 1 to it and then go on till it reaches the value 10, and then we know we are done. So we bring recursive this way, and we are creating a CTE, right? A CTE. So we need to give this recursive CTE a name. So we just say numbers. Let's name it numbers. As in a bracket, open bracket, right? As I stated, we're going to specify our first value. So select 1 as NU. That's what we will use here. So we're telling SQL that start with our value as 1, right? Just take 1 as our first value, right? And name it as NU. All right. So in SQL, we have union. Union simply means the first query that you computed just join, that is just produce the subsequent computation and just produce the values, right? So for example, if I have 1 as my first select here, right, whatever subsequent SQL or code that I write, and if it's under union this way, union simply means everything that falls within this particular code, just add them all together and provide me with the result, right? Union. And in Databricks, what works here is union all. In Databricks, you need to use union all. and then we produce another select. And now here we are going to call this first value, and we know the first value that we produced was 1. So recursive already knows that the first value we produce is 1. So what we'll tell it is nu, that is 1, plus add 1. So anytime SQL takes 1 here, it would add 1 to it and it will produce 2. And when it goes back, this will become 2 and it will add this to it, making it 3 until it reaches the value 10, right? So we call it as list, right? So this is what we want. So we pick it from which value? From the numbers, right? From here, right? Now what do we want? We want it to end where nu is less than 10, right? Because when this nu goes right on and on, it will reach 9, right? When it reaches 9 here and adds to this, it becomes 10, and then we want the query to break out, right? So we want nu should be less than 10, because if nu is greater than 10, we will produce 11, because nu will come back and add to this one, producing us with 11. But in this case, we only want it to be up to 10 as the scenario is. Now what we do is, this is a CTE, so we call the final result select. And in SQL, when we want to select everything, what we do is we use the star. So star from where, and we know the name of this first CTE is numbers, from numbers. Let's run this. Let's start a compute. The compute is off. Let's start a compute resource, which is serverless. It's beginning, right? And when we run this, what do you think the answer will be? What result should we get? Now let's wait. Now the compute resource is up. Now let's run it and expect. Let's see our results. But per the scenario, we said we want the SQL to run and produce values from 1 to 10. And this is the recursive query we wrote to be able to get us this particular scenario where recursive, there's a function called recursive in SQL. Then you give your recursive a name, right? A CTE, a recursive a name. Now you tell recursive which number is it SQL, which value should the recursive start from? And this is 2, 1, right? It should begin from 1 as the first value. Then go back, and 1 plus 1 should give you 2. And that 2 should go back and add up to 2 plus 1 should give 3, in that order until nu becomes 9, which is less than 10. And then it should break out of the recursive and produce me with a value, right? So now let's run this and see the results we get. So the compute is running, and let's refresh. Great. So let's run it again. Yes, so we can see we have the recursive worked and it's produced value from 1 to 10. So we can see this what it has. So at every stage, recursive takes the value, right, which you indicated as 1, and then runs it with a union and comes back here and adds to this. And then it goes, when it adds to this, it produces a new nu, which will be, for example, this being 1 adds up to this becomes 2, and 2 goes back with recursive, adds up to this one again, making 3, in that order until nu reaches 9, which would then indicate that nu is less than 10, and then it breaks out of the recursive and then produces me with a value. Great. This is how to write recursive query in SQL. So whenever you reach any interview and a live coding is given to you, a live coding test, yes, which is possible, a live coding test is given to you, you could, which refers to you producing a recursive query of values or numbers. This is the easiest way to do it, and they should score you and pass you through, right? Great. Now let's move on to doing the same thing in PySpark, right? And PySpark is pretty much straightforward and much more easier with a shorter line of code. Of course, we will still be using the DataFrame, right? And we know PySpark makes use of a lot. It's Python, so it makes use of a lot of data frames, right? So now let's create our notebook and name this PySpark underscore recursive. Great. Now, with this, what we do is we create a data frame, right? We create a data frame. And so let's write our data frame. In this way, we are not going to import any SQL functions anymore, right? We're not going to import any SQL function. But if we need it, when we run the compute, then when we run the code, it should tell us that we are missing something. Then we can tell if we need to add or import any functions. But let's go. Now let's create our first data frame. And you know, in PySpark, the Spark session is automatically started with when you are using Databricks free edition. Databricks automatically starts your Spark session for you, unless you are working with a local Jupyter notebook or a Jupyter workbook on your local machine. With that, you need to initiate your own Spark session all the time before you can run a Spark code, right, on your local machine. But with this one, Databricks free edition already initiates automatically the Spark engine for us, or Spark session, all the time. So we don't need to initiate any Spark session anymore. All we need to do is just write our code. Now let's name this data frame numbers underscore data frame, right? Equal Spark dot. Now Spark, we're telling Spark to create a range of values from 1 to 11. Starting from 1, produce a value and stop where you reach the next value will be 11. You just stop below it, right? And then you convert it dot to data frame. Name the data frame as NU this way. Then we display. We know every time we display into bracket number underscore data frame. We run and we wait and see the Spark engine what it will produce, right? Sorry, the data frame will fail because we only used a, we forgot to bring the S, so it will fail. That's why he underlined it. But let me bring it in and see if we can get that. Yes, as I said, it will fail. Let's run it again with the correction. Yeah, so this should run and produce us with the values as we stated, right? Great. So we can see we also produced a range, a value from range 1 to 10. This is pretty easy coding stuff that you can do, right? And there's another way of displaying this. Today, let me show you that. Sometimes you can use display, which gives a much more presentable view of the data, showing rows and columns and having something similar to database structure, right? A structured database, right? The display gives us that. And you can also choose to use this way, also show the value numbers underscore df dot show, right? And it should also give you, but it would give you in a different, now you can see the difference. Look at the structure of how this produced the values, the NU for here. Look at this structure. Now you can see the display produces much more better results, right? Much more better view or better shows much more better structure than using the show. So I'll say always stick to display, right? Display code. Stick to that, and then you'll be able to get a very good data to view, right? So yeah, great. So you've been able to create also numbers from 1 to 10 using PySpark. Let's move on to using SparkSQL. And we already know SparkSQL also makes use of SQL, but in this case, we put it into a Spark engine and use the Spark engine to run the SQL, which gives us that we leverage that distributed worker compute with Spark, which distributes the work for a lot of workers or a lot of compute resources to execute the code for you. So it's the same thing that we're going to write. We wrote in SQL. It's the same thing we're going to write in SparkSQL. But in this case, we use Spark to run the SQL. That's why it's called SparkSQL. Yeah. So let's create a notebook and name this Spark SQL recursive. Right. Great. Yeah, and we already also know that Spark SQL makes use of data frames as well. So let's begin by giving our data frame a name. And we still don't need to import any Python models in this case. We don't need to import any Python models in this case as well. So let's give our data frame name number df equal. Let's start our Spark. Let's call Spark dot, and we know we're going to write SQL. So we're telling Spark that we're beginning to write SQL. So SQL bracket open. Now we bring our quotation marks, 3 of it, from 3 for start, 3 at the end, open and close, 3 each on each sides, right? So 1, 2, 3 this way, and it produces that and gives you the cursor in the middle, and you just click enter and it gives you something like so. You can see we have 3 quotation marks at the beginning and 3 at the end, and that's how you write Spark SQL, and your SQL will be in the middle this way. Yeah, we want to indent our code very well for readability. So now let's begin, of course, with a with function, because we are going to create a CTE, right? With recursive, name the recursive numbers as bracket open. Now we write as CTE within it, just as we did previously. You need to begin and tell recursive SQL recursive that your first value is 1, as you name the 1 as NU, right? And then in Databricks union for recursive, in other data coding languages like other SQL dialects like PostgreSQL, or I think MySQL or other SQL dialects, you could just use union. But in Databricks SQL, you have to use union all for this recursive to work, right? So union all select, we create the next select function, select NU, get the NU from me. Then the reason why you have the union is because you are starting with the value 1, right? And we know 1 it's just is NU. We know 1 is NU, right? So NU plus 1, right? Plus 1 this way, and you give the end result, the value, as a list, or someone can choose to do it this way to make it much more understandable. NU plus this as a list, right? And where are you selecting it from? You're selecting it from numbers, right? because the first value that you get would be 1. The first value you get would be 1, right? Now, okay. And then where do the recursive break out? Where NU is less than 10, it should break out from the recursive, right? What do we do next? Now, when you break out, show us all the values you got from it, from your numbers CTE, right? And just as it is, we have this same as SQL, and then we can then display number. We display this data frame, right? Number underscore df. So let's run this notebook, the first one, and it has created this data frame for us, indicating the column as an integer, right? And then we run it to show the values this way. And then we should also have the same result as we did, 1 to 10. Yes, great. Sometimes some people prefer to write the display to look this way. Let's go to the next line. Some prefer to write it like an object oriented, right? Programming. So number underscore data frame dot display, open and close. But sometimes Databricks doesn't allow that. Let me see if this works. Yes, it did. Great. So some people prefer to write as object oriented this way, right? But I advise to write it this way. It's much more clearer, much more preferable, right? So great. Thanks. That is great. So we've been able to create a recursive query which produces numbers. As and when we run them, it produces numbers from 1 to 10. And we've been able to do this in SQL, in PySpark, as well as in SparkSQL. Now I'm sure you are prepared for your one-on-one live coding interview, right? You should be able to produce this and ease yourself of any stress or any pressure when it comes. That's great. See you on my next video. It's your favorite data engineer, Henry. Subscribe, like, and share my channel so that other people can also learn from this and also become great data engineers. Thank you. Bye bye.